Students, today we are gonna be starting our class 12th journey of mathematics. In the first chapter, I'm gonna be teaching you is of algebra. It's about matrices or matrix. So, what are these? What are matrix? You can think of matrix or matrices as like a coordinate system. It's basically like a coordinate system, two-dimensional coordinate system based basically made for determining the position of different objects or different numbers. For example, in a school there is only one row of benches that you can students in general can sit on. There is just one row of bench which includes three benches, and each of them can have four students at max. Actually, let me put it down this way with proper numbers. 6, 7, 8, 9, 10, 11, 12. Okay. So if the teacher of the class wants to uh, interact with a specific student, he would do. Let's assume that he doesn't know what the names of the students are. He would ask that, hey you from the first guy from the third bench, or if you're talking about the entire row, you would be the ninth guy. You stand up. Or if he wants to talk to, let's say, like a seventh guy here, he would say, you the seventh guy, stand up, like that. So you can think of this like uh, the x-axis. This is basically like a coordinate system, as I told you guys, which is used to express the position of a number of or anything, it can be anything, and it expresses its position using the coordinate system. Now let's say if there have been multiple rows like this. Let me actually take a larger bench. There are multiple rows and 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, like that. Now, if let's say if the teacher wants to interact with a specific student, like how would he do that? Like if he says that the third guy stand up. What does that even mean? The teacher has asked the third guy to stand up, but who is this third guy? Is it this guy, or is it this guy, or is it this guy? All three of these guys can claim that they are the third guy. This guy can say that, you see, this is the row, and I am the third guy who is in this row. This guy can say that, see, this is also a row, and I am the third guy of this row. And this guy can say the same that this is a row, and I am the third guy of this row. And you cannot deny that. All of them are none of them are lying. None of them is lying. From their perspective, everyone is third guy himself. Third guy himself. Herself, maybe. And I'm not here to discriminate in regards of gender. So if the teacher just says that, third guy stand up, that would be very problematic because there are three guys who can claim to be the third guy. But if he says that third guy from the second row of benches stand up, what does that mean? This is the first row, second row, third row. The teacher wants to interact with someone from the second row, and who is that person from the second row? The third guy. This guy, who has been labeled as number 15 here. He wants to interact with this guy. The third guy from where? From the second row. The second row is third guy. This is what basically matrices are. You can see that like if there had been only one row, then determining the position of the number, or in the specific example that we are discussing about, the position of the student could have been depicted by just one number, which in this case is just 3. But if there are more than one rows, that means there are more than one dimensions that the numbers, or in this case the students, can be arranged in. You definitely need more than one number to represent or determine their position. And let's say this guy, you can say that he is the sixth guy, but from where? Like this guy can claim to be the sixth guy, this guy can claim to be the sixth guy, this guy too can claim to be the sixth guy, all in their respective rows. You have to specify which row you're talking about. You have to say that sixth guy of the the second row is the one that I'm talking about. So basically, this is how matrices work. Matrices are basically like the way of you to determine the position of an object, or numbers who are basically like arranged in dimensions, in rows and columns. How are matrices represented? Let's see that. Let's check that out. Matrices are usually written down inside of third brackets or first brackets. This box parenthesis or this round parenthesis. Like this: A, B, C, D, E, F. Like here, A, B, C, D, E, F. This is A. So this is how matrices are represented, and each this one looks so cursed. Sorry for my poor handwriting. Let's say if you want to talk about this element of the matrix, which in this case is B. So how will you determine its position? You would say so the second element, basically the first guy from the column, which is this vertical side of the matrix, second guy of the first row, second column, first row, this guy we're talking about. This is how matrices are defined as. Now if you just write down a matrix like that, that won't make any sense. You have to write down the number of rows and columns into it. How do you do that? You do like this: I comma j, where I represents the number of rows in this matrix, and j represents the number of, sorry, you have to, that is like I cross j, where I represent the number of rows in this matrix and j represents the number of columns in this matrix. Now, what is the number of rows and columns in this particular matrix? It's 2 and 3, and we have to put a cross mark into it in between the numbers. And this is how a matrix looks like. A matrix, and in the bottom right corner of it, we are writing down the number of rows times, actually this is cross cross the number of columns. But you won't pronounce it this way. How will you pronounce it? You will pronounce it by. It is called 2 by 3, not 2 cross 3, not 2 times 3. Nothing like this. It's pronounced as 2 by 3. And not that creates a lot of confusion, but this is how just this thing is. Now, if you want to like you know represent a specific element from a matrix, and you don't want to determine, you don't want to talk about the entire matrix, how will you do that? Like, let's say you have a matrix here, 2 by 3 matrix. How will you represent that? First, let's say the first element is A, but here there's a little twist. You have to specify which row and which column does a specific element of a matrix belong to. In this case, this first element A belongs to the first row and the first column. This would be A11. You'll have to write down like this, how you represent an element of a matrix. You write down that element, and in the bottom right corner of it, write the the row it belongs to, and the column it belongs to. A, and let's say the second element. I'm writing down A as a general form of the elements in a matrix. So a little bigger there, like this A. This one would be, this one belongs to, of course, first row again, but then column number it belongs to is number 2. There is a third one. This one also belongs to the first row, but the column it belongs to is third one. There is a fourth one which does not belong in the first row. This is the first row, and this one does not belong inside of that. This belongs in the second row. And which column does this belong to? This one is the first column, and this and this element belongs in this range. So of course this is going to be the number of row this element belongs to is 2. And then the chronology basically, the column this element belongs to is 1. Then we are going to be having the second element, the second element of this row actually. So row number of this element would also be 2, and column number would be 2 as well. For the third element, of course, the row number would be 2 again. The column number would be 3. Okay. This is the first row. This is the second row. And this is the first column. First column. Second column. Third column. Okay, this is how you represent each individual elements inside the matrix. Now, the next topic is what are the types of matrix? Fundamentally, structure-wise, there are 2 types of matrix. First one is square matrix. Matrix is the singular form, and matrices is the plural form. Square matrix and rectangular matrix. Rectangular matrix. Pardon me for my terrible handwriting. So what are these? What is a square matrix and what is a rectangular matrix? In a square matrix, the number of rows and number of columns are the same. So the length, or you can say the magnitude of the two dimensions is the same. Like in here we have a matrix 1, 2. Actually, let me do it in terms of alphabets: A, B, C, D. So let's take 3 elements. That would actually make things look better. A, B, C, D, E, F, G, H, I. So as you can see, this matrix looks like a square. Why, you ask? Because this one has 3 columns and 3 rows. There's 3 columns and 3 rows. So if you connect these columns and rows, you would find out that this one kind of resembles the shape of a square. For the rectangular matrices, the number of this one is a square matrix. It's a 3 by 3 matrix, and in rectangular matrices, the number of rows and columns is not the same. They're different. And we have a matrix called A, B, C, D, and E, F, G. This is what? This is a 4 by 2 matrix. Rectangular matrix, you can see this is rectangular matrix and this is 2 rows and 4 columns. So if you connect these rows and columns, you will find that this one, in fact, this one doesn't in fact resemble the shape of a square. It looks more like a rectangle, and that is the point I'm trying to convey here. This one looks like a rectangle. That is why it's called a rectangle matrix, and this one looks like a square. This is why it's called a square. So yeah, I think there should I don't think there should be any problem, understanding what is happening so far. Let us end it here. Let us end the session here. I'll talk about the rest tomorrow. I'm not gonna keep the first lesson very long and very complicated. If you do find anything hard to understand in this lesson, then definitely do let me know in the comments, and I'll try to provide you with answers. Okay, so bye guys, see you tomorrow.